In this question, we have let n be a positive multiple of 5, and we have one red ball and n green balls are arranged in a line in random order. And we let P of n be the probability that at least 3/5 of the green marbles are on the same side of the red marble. And we're given that, observe that P of 5 is 1 and P of n approaches 4/5 as n grows large. We want to find the sum of the digits of the least value of n such that P of n is less than 321 divided by 400. So basically for this question, what you can do is first, let's try to understand the question better, because this might be kind of like a confusing question. It seems kind of complicated, but if a question seems kind of complicated and you don't really understand what it means, a good idea is to try smaller cases, right? So since n is a multiple of 5, let's just try some small cases just to see what they mean. So let's first look at the case when n equals 5. When n equals 5. So they already told us that P of 5 is equal to 1. They already told us that in the question, but let's see why is P of 5 equal to 1, just so that we can get a better understanding. So n represents the number of green marbles, right? So if n equals 5, we're going to have 5 green marbles. So I'll just write G for a green marble. We have 5 green marbles. Notice that no matter where we put the red marble, right? Since there's one red marble, let's say we put the red marble here, right? We want Pn to be the probability that at least 3/5 of the green marbles are on the same side as the red marble. Since we have 5 green marbles, then 3/5 of 5 is going to be 3, right? No matter where you put the red marble, you can put it there, you can put it here, you can put it here, you can put it here, or here, or here. No matter where you put the red marble, there will always be at least 3 green marbles on one side of it. For example, if you choose this red marble, you're going to have these 3 green marbles, and that's why the probability is 1, because no matter where you put the red marble, you have a 100% chance that at least 3 of the green marbles are going to be on the same side of the red marble. So that explains why P of 5 is equal to 1. And now they said P of n approaches 4/5 as n grows large. So that might seem kind of weird. But basically now what we're going to do is we're going to kind of find a formula for P of n, because that's what we kind of have to do in order to solve the question. So the next natural thing to try is, let's take a look at n equals 10, right? So n equals 10. So for n equals 10, you're going to have 10 green marbles. So green, 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 green. Right? And then you're going to have 1 red marble. So since you have 10 green marbles, then 3/5 of 10 is equal to 6. So we want the probability that there are at least 6 green marbles on the same side of the red marble. And just know that we're calculating the probability for the specific value of n. Eventually we'll get to the general case. So notice that you can put the red marble, for example, you can put it here, right? Because if you put the red marble here, the red marble goes here, then there will be 10 green marbles on the left side, which is greater than 6, so that's okay. You can also put a red marble here, right? A red marble here, because then you have 9 green marbles, and 9 is greater than 6. 9 is at least 6. Similarly, you can put a red marble here, you can put a red marble here, you can put a red marble here, but we cannot put a red marble here. We cannot put a red marble here. And that's because then if you put the red marble here, then you'll have 5 green marbles on one side, another 5 green marbles on the other side, but both sides have 5 marbles, and that's less than 6, so that's not allowed. So that means you cannot put a red marble here. But you're allowed to put a red marble here, one here, one here, one here, and one here. You can put a red marble in all of those places. So in this case, there are going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places you can put the red marble. And notice that there are 11 total locations you can put the red marble. So you'd have a probability of 10 over 11. And the reason it's 11 is because you have 10 green marbles, and you can kind of think about it 10 green marbles kind of separates the line into 11 spaces, right? If you have 10 green marbles, then you have a space here, a space here, a space here, and so on like that. And you're going to have 11 spaces, and 10 of the spaces you can put a red marble. So in that case, the probability is 10 over 11. So let's try to notice a pattern sort of. So the idea is like if you look, like we notice that like we can put a bunch of red marble. Wait, I change the color. Okay. Oh yeah. Okay. So notice that like we can keep putting red marbles, like starting from the right, we can keep putting marbles to the left until this number here is 3/5 times n, right? Like if this number, like if you put a red marble like here, for example, then like this number here would be less than 3/5 times n, which is not allowed, right? Because we need at least 3/5 of the green marbles to be on the same side as the red marble. So that means that since 3/5 is gonna represent like this like portion of the green marbles, that means this portion of the green marbles, that's gonna represent 2/5 of n. And notice that like if you have 2/5 of n green marbles, then there are going to be 2/5 of n plus 1, like kind of like regions that like the marbles are going to separate, right? It's like, I don't know if like when I say region, I don't know if that makes sense. Like if you have like for example 3 green marbles, then like you can put the red marble here, 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 or here. It's kind of like you have 4 regions, like 3 marbles divided into 4 regions. So it's like here, if you have 2/5n green marbles, it's going to divide it into 2/5n plus 1 regions. If that didn't make sense, please let me know. So that's the number of ways to put the red marbles on the right side. But similarly, you can use like symmetry, and there will be the same, there will also be 2/5 times n plus 1 ways to put the red marbles on the left side. Here we only consider the right side. So you have to multiply by 2. And as we already talked about, if there are going to be n green marbles, then that tells us that there are going to be n plus 1 like regions, like that the green marbles divide it into. So this is the probability. This is equal to P of n. So does anyone have, before I continue, does anyone have any questions on how we got the value of P of n? Like, do you guys have any like places in the process that you don't understand like what we did? Okay. All right, great. Okay, so we want P of n, which is 2 times 2/5 n plus 1. So this is our value of P of n. And the question told us that we want it to be less than 321/400, right? Like that's what was in the question in the beginning. We want P of n to be less than 321/400. So now we can just kind of solve the equation. We can multiply by 400 on both sides. So 400 times 2 times 2/5n plus 1 has to be less than 321 times n plus 1. So let's see, let's scroll down. So then we would have 400, and I can distribute the 2 inside. So I would have 4/5n plus 2 is less than 321n plus 321. And now I can distribute the 400. 400 times 4/5 is equal to 320, 320n. And then you distribute the 400 to the 2, you get 800. This is less than 321n plus 321. You can subtract 320n from both sides, subtract 321 from both sides, and you would get 479 is less than n. And the question wants the smallest possible value of n such that this is true. So what's the smallest value? Okay, why is there like, okay. So what's the smallest value of n such that n is greater than 479? Well, in that case, you would want n to equal 480. And the question asked for the sum of the digits of n. So you would do 4 plus 8 plus 0, and you get 12. And that was like, I think it was choice A or something. And yeah, that was choice A.